Hello, Maurieo. In this video I'm going to take a look at volume. Now volume is the amount of material or the amount of room or substance that something takes up, and volume is usually measured, or our basic unit that we're going to use for the measurement of volume is the cubic meter. So a cubic meter is in dimension 1 meter by 1 meter by 1 meter. In 3 dimensions, volume, we deal with 3 dimensions. So first up, we're going to be looking at the simple volume of a rectangular prism. Now, for all prisms, there's a basic formula which the volume of a prism is the base area times the height. Now you may well be familiar with a situation like this where we've got a fairly simple rectangular prism that it's just length times width times height, but it does subscribe to the base area times height, fits into that formula because the base area is length times width and then the height. So in this instance here, we've got, say for instance, A the length, B the width, and C the height. So we just put all those together and multiply them out. 30.13 times 52.24 times 20.04. Note that we've got all the meters in there, they're all meters, and then when we multiply those 3 numbers out, we get cubic meters, because meters times meters times meters, cubic meters, or meters to the power of 3. So multiplying that out, we get 31542.7836480, and so on, possibly more. And we're going to round that up to 2 decimal places, 31542.78 meters cubed, cubic meters, to 2 decimal places. Now the other thing that we're also going to be looking at with each or most of the shapes and that we're looking at is the surface area. Now the surface area might, if say for instance we were making a box out of say tin or paper, that would be the amount of area of, or the surface, or the amount of area of material or tin that we would need to make the hollow box, whereas the volume tells us the total amount of material that would, in a solid block, that would fit in there, we could fit in. So typically with surface area we work out what we call a net of the solid that we're dealing with, and in this case here we've got a net there that if we were to cut that out and fold it up, we could form the rectangular prism there. And you can see that I've put in the various dimensions there where they fit in the net. Obviously AB, the 2 labelled A and B are the top and bottom. The 2 A and C are the long sides, and B and C, typically we would call those the ends. So you can see how they all fit in there, and you can see also how there's 2 ABs, 2 ACs, and 2 BCs. The AB would be the area of that, length times width, B times A, as we can see here, and so on. So we can write that out as a bit of a formula for the surface area of a rectangular prism. It's 2AB plus 2AC plus 2BC, as you can see there. So we'll put the 2 outside the brackets and then multiply AB, AC and BC, filling in the appropriate numbers as I've done there, and we multiply that out and we get 6449.3720 and a whole lot of other numbers, and that will be meters squared because we're only multiplying meters by meters. 2-dimensional. Area is 2-dimensional, volume 3-dimensional, and the length 1-dimensional. And rounding that up, we get 649.37 meters squared. That's the area or the surface area to 2 decimal places there. So Next up, we're going to be looking at the triangular prism. And the triangular prism it has a triangular shape, and then that extrudes or comes all the way through. So no matter where you cut the prism at right angles to this triangular face, you'll always get a triangle. So the triangle prism shown here. Here's the triangular face. This is representing the height, and it goes through in that section all the way. So the formula for the volume of a triangular prism is the same as it is for any other prism, really. It's the base area times the height. But what varies here, of course, is that the base area is a triangle, and so we have involved here the area of the triangle, which of course is half the base of the triangle times the height of the triangle. So filling that in here, the base area is a half times 92.32, the base of the triangle, times 55.28, the height of the triangle, times 48.40, which is the height of the triangular prism. And again, we've got meters times meters times meters, so that's going to give us meters cubed. Multiplying that out, we get 123,503.48032, and off it goes. And rounding that, we get 123,503.48 meters cubed to 2 decimal places. And now looking at the net, so that we can work out the surface area. Again, I've filled in the various things there. Remember that we're dealing with the height of the triangle and not the height of the prism, which is there's two separate ones there. So I've shown the triangular height with a little triangle and an H there. So we can see we've got the two triangular ends, and the area of those would be a half base times height, with, in this case here, the base is C, length C, and the triangular height. And because there's two of those, it'll actually be equal to the base area. Well, it'll actually multiply out to 1, but the base area there is two of those, which is the base area, and then it's 2 times the base area plus A times H. There's only one of those, plus B times H plus C times H. So 2 times the base area, which as it turns out is a half, but we'll work with that as we go through. So we got 2 times a half the base, which is the 92.32, times the height of the triangle, okay, which is 55.28, plus AH, which is 72.41 times 48.4, plus B plus CH 71, or BH plus 71.62 times 4.84, plus CH, which is the 92. So they've all been filled in there in the various formula. And again, it's meters times meters. In no way do we multiply meters times meters times meters in this, because we were dealing with area. We get 16,542.7896 meters squared. And that's actually, because we're only dealing with 2 decimal places, there is no other. That's actually the full thing there, fully correct and accurate. But we're still going to round it to 2 decimal places, which is 16,542.79 meters squared to 2 decimal places. So, moving right along, we have the cylinder, or we could also call it a circular prism. And there's just a pretty much straight formula for the circular prism, which actually is the area of the base, which we know is pi r squared, times the height. So it does fit into the same category, but we tend to just call it pi r squared h. So we're filling in for pi times the radius. Remember, it's the radius, half the diameter, 15.05 meters, and that's squared. So that's where we get our meters times meters, because it's the radius squared times the height, which is in meters, which again gives us our cubic meters. So that's 17903.3173249. Rounding that, 17903.32 meters cubed. It's a volume, but we've got meters by meters by meters to 2 decimal places. Now, of course, the net, or the surface area, now gets a little bit tricky, but what we can see here is that we have two ends, which will have the base area, which is which was pi r squared. Okay, and we've got two of those, so that would be 2 pi r squared. And then we also have a continuous strip which would join them, and the length of that strip would be equal to the circumference of the circles that form the base and the bottom. So the circumference is 2 pi r, which is 2 times pi times 15.05, is 94.56. So that would be the length of the little continuous strip in there, or strip of tin, if, say, for instance, we were making a can or something like that. That would have a length 2 pi r. So that's where the 94.56 comes from. So now, working out the surface area, we get the side plus the two ends, and the area of the sides is length 2 pi r, and it has a height of h, which coincides also with the height of the cylinder. And added to that is 2 pi r squared, which obviously is the area, or 2 times the area of each end. So multiplying that all out, we get 3802.335562.085, and again it's meters squared. In all instances, we're just multiplying meters by meters, just 2 dimensions, and that rounds up nicely to 3802.34 meters squared to 2 decimal places. Next up, we have the square pyramid, or perhaps more correctly, the square right pyramid. A right pyramid is one where the vertex, or the peak of the pyramid, is perpendicularly above the center of the base. So it is possible to have a pyramid where the vertex is sort of not directly over the center of these here, but this one is called a right square pyramid. I haven't put the right bit in there yet, but we have a formula for this, for the volume, and it's a third the base area times the height. So it's 1/3 of the base area times the height. So in this case here, it's a third times, and this is a square, so the sides of the square equal 60 meters by 60 meters, and the height of the pyramid is 26.54. Okay, 26.45, correction. So multiplying that out, 31740.000 and a few other decimals, and typically 31740.00 meters cubed to 2 decimal places. Note that I have put the 2 zeros in there. Where we say something is 2 decimal places, there must be 2 numbers after the decimal place. So those 2 zeros are significant in the context of what we're saying here, that we have determined this volume accurately to 2 decimal places. Now the surface area presents us with a different sort of situation again. As you can imagine, we would have the 4 triangles all around the base. Now the area of the base is quite easily worked out. However, it is noticed that the area of the height of the triangles that form the face of the prism is different to the height of the pyramid itself. Because these are on the slant, they will be slightly longer. And further on, later on we will be able to use Pythagoras to confirm and work this out. But in this instance here, I have provided the height of the pyramid on the face. So again, the surface area is the area of the base plus 4 times the area of each face. And the area of the base is 60 meters squared because it's there. So that's 60 times 60, or 60 squared meters. So that gives us our meters squared. And that's an area, meters squared, plus 4 times a half the base, which is 60, times the height of the pyramids on the face, which is 40. So a half the base times the height. So multiplying that out, we get 8,400.00 meters squared to 2 decimal places, and that is the area of the surface area of this particular pyramid. Showing it there to 2 decimal places again might be a little bit OTT, but nevertheless not incorrect. And that brings us along to the right cone. There, this time I've got the right thing in place. And the right cone, again, similar to the right square pyramid, is a cone where the vertex of the cone, or this high point here, is directly over the center of the base. Now, in this one here, we just have a straight formula. The volume is 1/3 pi r squared, which is the radius of the base, times the height. Note again that it is the height of the pyramid, and that we have again another factor here called the slant height, which, as I indicated, can be worked out from Pythagoras. In this case here, I've used a 3, 4, 5 triangle for those of you that are familiar with Pythagoras. So that will give us a slant height. So the volume equals 1/3 pi r squared h, which is equal to a half, times pi times 30 squared, which is the radius, 30 meters squared, times 40 meters, giving us meters squared times meters, giving us our cubic meters. And that works out to 56548.66776,462 meters cubed. And we round that to 2 decimal places, 56,548.67 meters cubed. Now, the net of a right cone is quite interesting. Obviously, the base will be a circle, radius 30, and the cone bit, or the upstanding bit, will have a radius equal to the slant height, which is 50. This distance from here, the arc length of it, will be equal to the circumference of the circle of the base, as it turns out. And we can work, knowing the circumference of this circle here, we can work out the circumference of this circle here, and we know what this radius has to be. So from that we were able to work backwards through various formula to work out what this angle is here in order to achieve this cone. However, we have a formula for the surface area of a cone, and we're going to use that in this instance. But just be aware that the mathematical possibilities are there. And the formula is pi r squared, which obviously gives us the area of the circular base, plus pi r, which is the radius of the circular base, S, which is the slant distance. So in this case here, it's pi times 30 meters plus pi times 30 meters times 50 meters. 30 meters squared. Pi times 30 meters squared to give us our square meters, plus pi times 30 meters times 50 meters to give us more meters squared there again, but only meters squared. Multiplying that out, 7539.822368616 meters squared, and rounding that is 7539.82 meters squared to 2 decimal places. Our final shape is the sphere, which is the ultimate in circular objects, a solid object where every point is the same distance from the center of the sphere. We just have a formula for both the surface area and the volume. Note that I've given the diameter here and the formula require the radius, so just doing a simple calculation here, 23.56 divided by 2, 11.78 will give us the radius. So the volume is 4/3 pi r cubed. The r cubed will give us the cubic meters. So 4 divided by 3 times pi times 11.78 to the power of 3. You might want to, there's two ways you can do the 11.78 to the power of 3. You can, I've indicated over here, it's the same as 11.78 times 11.78 times 11.78, which is 1634.691752. Okay, but on some calculators you have a y to the x key. And so you are able to enter in 11.78, enter that into the Y register of the calculator, put a 3 in the X register of the calculator, push the Y to the X button, and that should give you 11.78 to the power of 3. And it should be 1634.691752. So moving right along and back to the formula there, we can multiply all that out. So that's 4 divided by 3 times pi times 11.78 cubed. That will be cubic meters. 6847.380,798,623. And that's 6847.38 meters cubed, 2 decimal places. Surface area is 4 pi r squared, just a formula that you could look up, or you would generally in most maths tests and things be given the formula. So that's 4 times pi times 11.78 squared, 1634.691752 meters squared, 1634.69 meters squared to 2 decimal places. So the sphere, some notes here on the sphere. Impossible to make a perfect sphere according to this information here. Most sort of spheres that we were familiar with are approximations to the spheres. And if you think of maps and globes and things like that, of how trying to stick a bit of paper onto a spherical surface or a ball or whatever, it's very difficult. So a little bit of notes there, a little bit of further reading for you if you can get hold of the notes and what have you, and or you can just stall the video and you can sort of have a bit of a read there. So that's pretty much it on volume, although I just have one final little slide that I'm going to talk to you about and run through with you before we finish. Okay, in this little slide here I've made up on a little Excel spreadsheet, I want to get across the concept of length, area and volume. Length being a one-dimensional, we just measure a length, one dimension. Area, the amount of surface, 2 dimensions, a length and a width. And volume is the quantity or the amount of matter or the quantity of a thing, like how much air is in a room or how much, what the space is, and that has a third dimension. So each one of those dimensions is indicated by, we have meters for the length, meters squared for the area, meters cubed for the volume. Now this brings with it some various little things. So whereas if we have, say for instance, 1 meter, that's 100 centimeters, and it's 1,000 millimeters. But when we look at a square meter, 1 square meter is 1 meter by 1 meter. Okay, is a square. So square centimeters, now each of those meters is 100 centimeters. So we're going to have 100 centimeters by 100 centimeters. So that's going to give us 10,000 square centimeters. So 1 square meter, 10,000 square meters, square centimeters. 1 square meter, 10,000 square centimeters. And going the next step to millimeters, a meter by a meter is 1,000 millimeters by 1,000 millimeters, which is 1,000,000 millimeters. A square meter is 1,000,000 square millimeters. Okay, now when we move that along to volume, it gets even bigger. So we've got the cubic meter, which is 1 meter by 1 meter by 1 meter. Okay, and that's 100 centimeters by 100 centimeters by 100 centimeters. So that's going to give us 1,000,000 centimeters. 1,000,000 centimeters. And then going down to millimeters, 1,000 millimeters by 1,000 millimeters by 1,000 millimeters. That's going to give us 1,000 million cubic millimeters. 1,000 million cubic millimeters. Very large numbers. So when you're dealing with area, you must be very careful, or area and volume, you must be careful, very careful how you deal with these numbers, because it can be very easy to lose track of your tens and thousands and be quite considerable amount out. So take care working with area. Extra dimensions means extra zeros. And then just a few other little things about area that you may be familiar with, is particularly if you're in a rural situation. The hectare is, there actually is a thing called the ARE, the ARE or an R, and the hectare is contains so many of those, can't quite remember at this point. So it's 10,000 square meters. I think an R is 100 square meters, so there's a hectare. Hectare is 100 of them. I'm not sure. Oh no, there might be 1,000 square meters, and there's a hectare is 10 of them, depending on whether whatever the right pre-thing is, like milli, centi, and what have you. But that's something we'll need to confirm at a later date. Now, it's approximately 2.5 acres, or 100 meters by 100 meters. That's a hectare. Now, an acre, which is an old imperial unit, is approximately 4048 meters squared. I've made it 4048. Technically, it's probably 4047, but a quarter acre is pretty much 1012 square meters. So I'm saying approximately that. And a hectare is approximately 2.5 acres. Now, also good to know that a litre of water has a volume of 1,000 cubic centimeters and weighs 1 kilogram. You'll probably, if you're familiar with cars, a 2-litre car is a 2,000 cc's. 3 litre car, 3,000 cc's. cc's being cubic centimetres. And it weighs, if it were the equivalent in water, weighs 1 kilogram. A milliliter of water has a volume of 1 cc. A milliliter of water has a volume of 1 cc. And that is equal to 1,000 cubic millimeters. 1,000 cubic millimeters. So they're just some little interesting facts and bits of information that when you're dealing with area, length, area and volume, may be of some help to you.